The second example for higher order derivatives contains negative exponents. The small negative sign changes the whole derivative result. Welcome to differential calculus. Let's have a peek of higher order derivatives. The first derivative, which everyone is already familiar with, is also written as y prime. But this is interpreted as dy over dx. In physics, aside from having the first derivative as a slope, it is also termed as the rate of tangency, velocity, or force. A derivative higher is called the second derivative, which can be called y double prime. So from dy over dx, take further derivative, which then can be written as the second derivative of y with respect to x. This type is also termed as the rate of curvature, acceleration, or yank in physics. Further down the line, a higher order derivative is the third, which can be termed as y triple prime. And taking it from the second derivative, we take its derivative again, resulting to the third derivative of y with respect to x. This is also called jerk or tug. There is also the fourth derivative, and this time we can term it as y quadruple prime, but it is still written as the fourth derivative of y with respect to x. This order is also termed as jounce. Instead of 4 primes, this is denoted by y raised to 4, and of course enclosed in parentheses, which makes it different from the exponent 4. The problem requires the third derivative of the function y as equal to negative 2x cubed minus 4x raised to negative 3. In order to reach the third derivative, the process has to start with the initial differentiation. So take the derivative of both sides of the function, thus creating dy over dx. The next step is to distribute d over dx among the terms in the binomial, making dy over dx as the derivative of negative 2x cubed minus the derivative of 4x raised to negative 3. As the terms get simpler, we start the computation by placing out the constant. This is the constant multiple rule. So dy over dx then starts with the constant negative 2 with the derivative of x cubed, and also the constant 4 with the derivative of x raised to negative 3. With simpler terms with d upon dx, we can now differentiate. Dy over dx is negative 2 times the derivative of x cubed, which is 3x squared, then dx over dx, minus 4 with the derivative of x raised to negative 3, which is negative 3x raised to negative 4, then attach dx over dx. From both terms, cancel out dx over dx as they are 1. This then gives the first derivative of y with respect to x as negative 6x squared plus 12x raised to negative 4. We can now continue with the second derivative. So from the current derivative, differentiate it once more, and then distribute d over dx among the terms. The second derivative of y with respect to x then becomes the derivative of negative 6x squared plus dx over dx of 12x raised to negative 4. With the usual process, set aside constants and have y double prime as negative 6 with d over dx of x squared, and also 12 with the derivative of x raised to negative 4. The derivative at this point is so much simpler to process than earlier, as they are just individual terms. So let's differentiate. Y double prime then has negative 6 times the derivative of x squared, and that is 2x. Then attach dx over dx. The second term starts with the constant 12, with the derivative of x raised to negative 4, which is negative 4x raised to negative 5. Then add dx over dx. Again, cancel out dx upon dx as they are 1, to have the final second derivative of y with respect to x as negative 12x minus 48x raised to negative 5. So we are at the last differentiation as we start the third derivative, where we take the current derivative and differentiate it again. We then distribute d over dx among the terms of the binomial and get the third derivative of y with respect to x as the derivative of negative 12x minus d over dx of 48x raised to negative 5. The following step is to take the constants from the d's, so the derivative now becomes negative 12 with the remaining term differentiated. Attach to this the constant 48 with d over dx of x raised to negative 5. Dx upon dx is 1, simplifying the whole derivative as negative 12 with the second term starting with negative 48 and the derivative of x raised to negative 5, which is negative 5x raised to negative 6, with dx upon dx. The last part is again cancelled into 1, so the third derivative of y with respect to x, or y triple prime, is negative 12 plus 240x raised to negative 6.